This is the wafer after photolithography.
I've been doing some microfabrication, and in this video I'm going to be explaining what I've been up to, the machines I've been using, and all of that fun stuff. Basically, the goal of the process is to have a muscle fiber that I can control electrically. The design is based on electrostatic actuators. Compression happens because the positive and negative electrodes attract each other in a charged capacitor structure. And by stacking a bunch of these one on top of the other, you get a muscle fiber. I've been tinkering on this design at the Toronto Nanofabrication Center, and it's been really fun. The process happens in a Class 10,000 clean room and a Class 1,000 photolithography area. The rooms are ventilated to minimize particles in the air, and I have to put on a suit and hairnet and all that stuff to minimize the amount of particles. Before getting started, I did a bunch of research and prepared a process flow document with all of the steps I was going to perform. So I start off with a clean SiO2 wafer. The choice doesn't matter too much since later on I'm going to remove the actuator from the wafer anyways. But the first step is sputtering for the bottom electrode. Now originally I was going to do E-beam evaporation for 2 micrometers, but because the first attempt was more of a dry run to test out the machines anyways, I decided sputtering 200 nanometers of aluminum was good enough. Also in the process, I was originally thinking of depositing a tiny layer of gold to protect the aluminum from an oxide layer, but I realized that later on the probes would be able to pierce the oxide film anyways for making contact during characterization. And another thing is that originally I had a step to spin coat photoresist before depositing the bottom electrode, so that later I could dissolve it and detach the microactuator from the wafer. However, I decided to skip this for the first run, since I'd be able to characterize the displacement with the probes more easily if the actuator is stuck onto the wafer. Next step was the PDMS spin coating. I mixed the Silgard 184 monomer and curing agent in a 10:1 ratio, then degassed the mixture in a vacuum chamber. I added it to the wafer and spin coated it at 6,000 RPM for 5 minutes. This should have resulted in a 5 micrometer film. Then I cured it in the oven for 15 minutes at 150 degrees. The next step was to repeat the first step and deposit another 200 nanometer layer of aluminum for the top electrode. I actually ran an O2 plasma etch in the sputter machine before starting aluminum deposition to increase the surface roughness, which hopefully increases the adhesion of the aluminum layer. I also did some probing to make sure I deposited the right amount of aluminum. I also did this for the bottom electrode, but didn't mention it. Then I got ready for the photolithography and etch steps. First, I spin coated some S1818, which is a photoresist, and according to the lab recipe, I had to spin coat it at 500 RPM for 30 seconds, then 3000 RPM for 45 seconds. After doing spin coating, I put it on a hot plate at 90 degrees for 1.5 minutes for a pre-bake, and then the next step was the UV exposure step. And so for that, I used the photo mask. I used the L-edit to make the pattern, and the pattern is pretty arbitrary anyways. The main purpose was just to have a bunch of actuators of different widths. So I have circles, squares, ranging from 5 micrometers all the way to 1 centimeter. I then exported the file to GDSII and sent that to be made into a photo mask. Anyways, after exposing the resist with UV light for 7.5 seconds at 800 watts, I did a post-pattern bake and then developed the photoresist with the photoresist developer. And after that, I cleaned it up with deionized water. Now, at this point, the next step would have been to do etching. And originally, I was planning to do dry etching with reactive ion etching of both the aluminum and PDMS layers, but actually the reactive ion etching machine at TNFC doesn't have the power to do aluminum dry etch. So instead, I was going to do aluminum wet etching, but when I went to start the process, we thought that we had some aluminum wet etchant at TNFC, but it turns out that we ran out recently. So I had to order some from Transcene, and it should be arriving next week. So I've decided to split this video into 2 parts. But anyways, when I'm back in Toronto, I'll post a follow-up video, so stay tuned for that video. That's it for now. See you next time.